do-it-yourself septic system that we just put in, and kind of why and how and what we did and what it takes to do it yourself. Those of you who follow me know that we've been doing pretty much everything ourselves out here on our homestead. We've installed our own solar. We've buried over 2,000 feet of water lines in various places. We built our own road, built a bridge over a creek, and now we're getting ready to start on our house. And before we wanted to do that, we needed to get the septic system in so that there's no surprises later on once the house is built. The last thing you want to do is build your house first, only to find out that one spot you had for a septic system is where a huge rock formation happens to just lie right underground. So we wanted to get the infrastructure out of the way so that when it comes to building the house, we don't have to worry about anything but getting it done. So to do it yourself, we're handy do-it-yourselfer type people, but we don't have a construction background. We don't have an engineering background or anything like that. We just watch a lot of YouTube videos. We do a lot of studying, we do a lot of reading, and we kind of learn as we go. We put in our own solar system. We're completely off-grid with power. That was a huge project. I went into it knowing virtually nothing about solar, and now I know it all at the back of my hand. Special thanks to Scott Hunt for helping me out with that. He's Engineer775 here on YouTube and owner of Practical Preppers LLC. He's where we got everything, and I highly recommend looking those folks up if you're going to do an alternative energy project. But anyway, what we did is, which I'll explain. So this pipe would be going toward the house. The house would be up on a high spot here in front of where the backhoe is. So the house doesn't exist yet, so we just got that capped off. And we wanted to be far enough away from the build site so that we can be running around with cement trucks and everything and not worry about anybody accidentally running over the tank. So we wanted it downhill a bit. The rule is that you can be up to within 5 feet of your house, but to us, building the house and having a tank right there would have been a hassle. So we just brought it on down the hill a bit. And this tank is an Infiltrator brand tank. It's a 1,080 gallon 2-chamber tank. The state of Tennessee requires 2 chambers, and I'll explain how that works. And you can use either concrete or you can use a plastic tank like this. We opted to use a plastic tank so that we could use our own backhoe to lower it in the hole. If there was any fitting that had to be done or leveling, if our hole wasn't just right, we could pull it back out ourselves, do the work, lower it back in, instead of having to have a crane truck come back out. Or if our best thing to go down the hill is if the height of our outlet invert, which we'll talk about here in a minute, wasn't right in relation to the top of the chambers for the leach field on down the hill, we would have had to have the tank pulled out, maybe put some fill in the bottom and set it back in to get those vertical distances right. So with a plastic tank and having our own backhoe, we could pull it in and out of the ground as many times as we have to without having to have the crane truck come back out. So for us, plastic was a no-brainer. They're made really well. This one's got steel supports in it. You can jump up and down on it. It's not a floppy, soft tank. It's very sturdy. So how the system works, starting with the tank, your effluent, to use the official term, comes through the pipe from the house, and it goes into this T, and the T reaches down into below the water line. So the point of this is that the sludge is supposed to be able to float on top of the water or sink to the bottom. And in the middle, you got sludge and you've got your solids on the bottom. In the middle, you should have just water. So at about that point, 2/3 down the tank, there's 2 holes in this bulkhead to allow just the water to flow through into the second chamber. Now the bacteria and stuff that's in here should be breaking those solids down. When it gets broken down to the right amount, water flows through into the second chamber. More of that digestion continues. And on this side, there is a outlet T. You'll notice this pipe is lower than that pipe. Those T's are different heights. That's because the outflow obviously needs to be lower so that when the water level gets up to the point that it needs to discharge some water, it only goes one way. It only goes toward your drain field and not back toward your house. In the state of Tennessee, you drill those holes yourself because the tank comes with, as you can see one here, there's on either side and the end on both sides, you can decide whether your inlets or outlets come into the side of the tank or come in out of the end. Either side, you can come in one side, out the other. In Tennessee, you've got the legal flexibility to do that yourself. In some states, like Kentucky right above us, the holes are pre-drilled. You don't get a choice. That's where they're going to be. So you got to make sure you get those heights just right, and then you got to install those tees yourself. So as the water, the same thing happens in this tank, where the outlet tee that's on the end of this pipe reaches down below the sludge layer, somewhere around the middle of the water, so that it's just water. And then as the fluid rises, as more effluent comes into the tank, that water rises inside that tee, and then it's able to go down the outflow pipe. So our leach field system is, we used Infiltrator brand Quick4 chambers. And the Infiltrator Quick4 chambers, these plastic guys down here under this dirt, they're like a half tunnel, and they're louvered on the sides. So the theory is that the water, that what is now considered treated water, once it leaves the digestion process of the tank, comes down, enters the chamber, and the chamber keeps it from rising up and just forces it down and out. And then it's supposed to basically just kind of leach into the ground and work itself back into the world's system that way as treated water. So the very top of this chamber right here is the point that has to be lower than the bottom of that inlet tee, and that inlet tee reaches 24 inches down into that tank, so this has to be substantially lower in that tank. So when you're laying out your system, don't just put things where you like it. You have to vertically align everything, because that would not only fail your system with your inspection, but it would cause your system to not flow properly. So our effluent comes out of the tank, goes into the first chamber here, and this is set up because we're on a slope in a serial system. So in a serial system, the water comes into this tank, or this chamber system, well, completely fills the full length of this 60-foot trench, and then it cuts across. Once this is full, it cuts across at a high-mounted outlet that goes to the next trench. And you can see one of the relief lines here about how that works. Once this chamber is full, it comes out of the top here, which is at the top above the louvers on the side. So this chamber gets completely full, and then it flows through that pipe, which is level, and then down into the next one. So you can go in the top and out the sides so that everything flows properly in the right direction. And we've got 4 trenches total, which it's 60-foot trenches, 59 foot of material. It's 236 feet total of leach field chamber. Our requirement was for an old school system of perforated pipe and gravel, 300 feet based on our soil score. Because our soil score fell within 10 and 60, it was 45, which is really good. We were able to reduce the length of our system by 30%, giving us a minimum of 210 feet of chambers. So we've got 236, so we're a little over that. So we tried to add cushion into everything we did. You're supposed to have a minimum of 6 feet of undisturbed earth between the trenches. We made our minimum 7. So whatever the legal minimum was, we just added a little to it, padded it, made the system a little more robust, and gave us more leeway when it came to the inspector speccing things out. So one of the things that you'll definitely need when you're doing a system like this, other than something to excavate with, like we had our own backhoe, but we ended up renting a Wackernussen brand excavator, because they've got a tilting undercarriage where you can adjust the machine on this slight slope to get the bottom of the bucket perfectly level, so that the bottom of the trench is perfectly level. We used our backhoe for the first 2, but moving the backhoe around and putting a cross tie under the downhill outrigger to lift the machine up high enough to get the bucket level, that was just taking up so much time. We decided it would be worth to spend a little money and go rent the excavator, and it literally did twice as much work per day than the backhoe, so I highly recommend going that route. If you're on fairly level ground, you don't got to worry about the tilting thing, but it sure did make things nice and easy. Other than that, you need a laser transit, because these trenches, these are 60 feet long, and they're required to be within 2 inches of level from one end to the other. Using a laser transit with a surveyor's rod with a laser sensor on we were able to get everything within a ½ inch of perfect, both side to side perfect and within a ½ inch the full length of this, and they're all that way. The same thing with getting your relief line trenches level, and checking the height of your first chamber in relation to the outlet invert T. So really, I can't think of another way you could possibly measure that without using a surveyor's rod and a laser transit. So definitely got to have one of those, and then just something to excavate with, and a stretch of sunny weather, because can you imagine trying to do this in the rain, in the mud? Once you get started and it rain, it would be a nightmare. So we've been blessed with the weather, blessed with the time off from work, and blessed with the ability to have the right tools and equipment to get it done. So here in the state of Tennessee, especially here in rural Tennessee, where everything's different, our local inspector that's in charge of all of this, he is super supportive of people doing do-it-yourself projects. He feels that the homeowner is going to take more care and more pains into making sure everything's perfect because they want their system to work right than even a contractor will. And so he's super supportive and helpful. We were able to call him anytime we had a question. And the state of Tennessee also gives a class, which is kind of like a test that they send you pre-study materials for, and then there's kind of a briefing, question and answer, stuff like that before the test. And it's basically the state licensed installer certification test. So I took that and passed it because it was the recommendation of my inspector, and hey, he's the one signing me off, so whatever he wanted me to do, I was going to do right. And it really did pay off. It gave me all the book knowledge that goes along with all the rules and regulations on how to get all this stuff right to be able to pass, not just to get your system to work properly, but to fill in all the gaps and check all the boxes for the legal aspect of it. So I definitely wouldn't want to do it for a living, but I'm definitely glad we did it ourselves. We know everything in the ground on this property like the back of our hands because we've done it all ourselves, and we're going to continue to do that, including what's built on the house. There's something you can't explain that adds value to everything when your own blood, sweat, and tears have gone into it. And you see these little toy dinosaur eggs everywhere. Our little girls have been having a field day out here. This has been like a playground for them. But unfortunately, I'm about to have to cover their playground up. And speaking of covering it up, we just passed our inspection this morning, so now I can legally cover it. And since it didn't rain, all this should be nice and flowable and should fill in really nicely. With the width of this trench being 36 inches, Infiltrator, the manufacturer, recommends that you use a tracked vehicle to backfill, because even a big tractor tire is going to sink into this hole as it goes over, and that's going to put pressure in certain spots on these chambers. Now, once all the ground is in there and the settling takes place and the ground compacts and hardens back up, you could drive over it. But when it's soft dirt, you're going to sink into it and put pressure in certain places on the system. So if you use a tracked vehicle, the tracks equally distribute weight, and they're able to cross this trench without dropping over into it. So we've got a small bulldozer that we bought when we first bought this property to build our road, so I'm getting ready to fire it up and use it to cover all this. And once you initially cover it, don't smooth it out and make it pretty yet. Wait for that initial settle. Anyone who's ever dug a trench, water line trench, electric line trench, or whatever, knows good and well that after a few rains, it sinks in and now you've got a ditch instead of a hump. So after the initial settle takes place and everything kind of fills in and compacts, then go back over it at that point and re-level and smooth everything out. Otherwise, you're going to kind of have this wavy thing going on in your yard, and you're going to have depressions where water's going to build. And if water's going to build and sink down into your chamber and keep your chamber full of rainwater, it won't be able to handle the water that's coming from your house properly. So follow the instructions. I know a lot of people out there have got a lot of experience running machinery and stuff like that, but when it comes to things like this, if you had to get in here and fix your system later on after it's full of waste, that wouldn't be a very fun job. So get it right the first time so that you can just walk away and forget it and enjoy its perfect function. So anyway, I hope you got something out of this. Hope it wasn't overly technical, but I wanted to let you know everything that kind of goes into doing this yourself. It's definitely possible as long as you're willing to put the time and effort and the study into it, and I highly recommend it. So thanks for taking the time out to watch, and we'll talk to you later.